Hello, Seoul. How are you doing? So my name is Sriwantha Attanayake. It's a very long name. I'm a principal solution architect based out of beautiful sunny Sydney in Australia. I'm super excited to come here and then talk to you about all the .NET development activities happening in AWS. So myself and some of my colleagues over there are part of Microsoft team inside AWS, and we have a very large team helping customers and partners like you to build on AWS. So I'm a .NET developer. I've been with AWS for about 7 years. Prior to that, I was a .NET developer like you, building .NET applications for a French investment bank. So today I'm super excited to walk you through some of the innovation that we are doing on AWS front. This is this is where you press it, right? Alright. So we have been running Microsoft workloads for a long time, and during that period, a lot of innovation that we brought into the customers like you to build on AWS. So when .NET developers come to us and say that we'd like to program using our favorite SDKs, of course the SDKs was released. When they say we'd like to program for our servers using C#, that came up. And also all our APIs, all our platform is available on PowerShell. If you like to program using AWS and for command line, that's available for you. So that's the whole idea here is to make it accessible to the widest possible audience as possible. A little known fact about AWS is that we are a Microsoft partner, and it's very important for us to have a really good relationship with Microsoft. So some of these technologies we build with them. And AWS is also a very important part for Microsoft because there's a large revenue that we drive for them when you run Windows instances or SQL Server, for example. So there's multiple tools available. Most of our tools are integrated with your favorite IDEs like Visual Studio, if you want to program for PowerShell. I'm also going to do some demos how to integrate AWS services with Azure DevOps. To get an idea like how you can keep using your favorite Microsoft tools at the same time integrate it with best of class services with AWS. So before we go into .NET stuff, I really want you to focus on some changes happening in the industry. Let's go back 50, 60 years back in timeline and really try to understand what is happening, right? So this is like a 30,000-foot overview of what is happening in the industry so that you can actually plan in your career, hey, this is something that we should take serious. So back in 1966, we landed on the moon, and the computer that navigated the moon landing was a very small, capable computer. It could do only about 12,000 odd floating-point operations. Right? That's great. So this small computer landed the man on the moon. Moving forward, about 20 years later, we have this great supercomputer by IBM, of course. It could do about 1.9 billion floating-point operations, about 150,000 faster than the computer that landed the man on the moon. But it cost about 30 million plus US dollars to build it. Right? That's great. Another decades later, you see that you ask, like, what is this odd shape of this computer? It's like a hexagonal, right? The reason why they created this hexagonal is that it really helps to reduce the distance of wires available on the. So here you can see the all the things packed with wires. So that special shape is to reduce the distance of wires so that you can have fast computers. And each one has these modules. So back in the days, they didn't have the capability to build multiple layers on the PCB. So you can see that these layers on the PCB are actually visible. Interestingly, this CPU consumed about 150 to 200 kilowatts. That's enough to power several households, right? Now, of course, you have these chips around Apple A14, for example, over 11 billion transistors, and 5,000 times faster than the Cray supercomputer back in the days. So the Cray used to do all the nuclear simulation, and now we are playing Candy Crush Sugar on this small chip, right? And it's similar for Samsung chips. So what you can see is that over the time, the power of computers, the capabilities, how you can program for this, is always increasing. So this is of course the Moore's law. More and more chips are getting very powerful. We know that because these are the games that we used to play, right? And hands up those who grew up in this era where we used to play these kind of games, right? In the audience, yes, we have some, right? But fast forward today, this is the quality of the games, the high resolution that we are playing today, right? And it's all thanks to this advancement in the CPUs and the GPUs and all the network here. So what we as developers or what our users as first we experience the application that we are using is just the tip of the iceberg. Now to drive all these crazy applications, we have these APIs that we developers use. But underpinning these APIs are all the technology advancement that we had. So that includes improvements in the compilers. How many of you are going to when a new version of .NET is released? Microsoft usually releases a description about how they have improved the performance of the underlying .NET platform. So you really need to pay attention to that because that's what actually drives all the innovation on top of this. Sometimes it's investments. Now, when Internet boomed in 2000, there was a lot of infrastructure spending on broadband internet. And that investment is what led into the internet revolution. So we need to look at, when you are a developer, this is something that we ignore. So pay attention to what is happening on the fundamental physics, the mathematics, in compiler technology, and that can give you an idea around what the future is going to look like for all the technologies that we have in place. So, we all know we had a great time with .NET Framework. It was released somewhere in 2002. I started programming when it was complete version 2.0. But over the years, Microsoft had done a great job coming up with the latest version of this .NET Framework. But somewhere in 2016, they released .NET Core. Back in the days, it was just somebody's project on an open source community, but it got so much traction. Later, Microsoft officially announced that .NET Core, starting from 2002, .NET 5.0 is the official version. And moving forward, there won't be any new releases for .NET 4.8. So that's the last version. Which means that there won't be any new feature releases of the .NET framework that only runs on Windows. And some of this reason was actually the innovation that happened in the .NET Core side and the market changes that happened. So when first .NET version 4.1 was released, I was like, nah, it's never going to be successful. I don't know whether you were in that crowd. So until .NET Core 2, I was thinking this will never have a future. But the stark realization I came to know was when Microsoft officially announced that 4.8 is the last version. Every greenfield project I see the customers are built on .NET 4. And there's a huge number of applications now getting transition from .NET full framework into .NET Core. Right? So that change is happening, and why it is happening is the next question. So one of the things that we need to realize is that one reason why the customers are moving from .NET Full Framework into .NET Core is they need to harness the power of new chips. So ARM is so popular now in the customers that they really want to migrate into ARM-based processors, and the only way they can do that is to use .NET Core, move into Linux, and get the power. So over the years, you can see, for example, this is our versions of Graviton. It's the AWS version of chips. And it's across the board. You can see, especially large-scale ISVs, gaming companies moving their heavy workloads into ARM-based processors. The reason for that is you get really good price performance compared to x86 architecture. For example, the Graviton 2 has 40% better performance for a dollar spent compared to x86 similar architecture. Right? So this movement is going to happen. And in the future, you can see better and better processors coming into market. Have you guys done any hardcore .NET performance tuning? Raise your hands who have used Visual Studio Performance Profiler or ANS Performance Profiler. Who has done .NET performance tuning? Raise your hands. We have one here. Some more? The challenge when you try to performance tune a .NET Core .NET application is that it's very hard. Right? You may use maybe async methods, you may use task parallel libraries, or if you have a very hardcore program that you want to optimize, you may use things like system span or system memory. But the challenge is they are so limited when you have a large code base. It's very difficult to go there and then go line by line and then optimize. To give you an idea, let's say you have a code base like this, right? So here I have two external libraries that I'm calling, and I want to get the, my task is to reduce the execution time. But unfortunately, I don't have control over these external library calls, right? So this may take maybe 150 milliseconds, 250 milliseconds, and how can I go there and then optimize this code? It's very difficult. Now you may think, all right, this is just 400 milliseconds, so what's the matter of that? Now imagine that this method is called 1,000 times, right? And it's very common, especially on rendering engines, that you do this. If you have done any 3D programming, DirectX, these kind of programs are you really need to optimize them. The challenge is that you don't have much control of external libraries. The other challenge is that, let's say you have your code base, you have about 100 lines of external calls or like calls to your libraries, and all of a sudden you have this 10 nanosecond here, 7 milliseconds here, and it's very difficult to drill down into the code and then optimize it. That's why like customers are more and more looking into better chips to make it more efficient and then improve the performance. So pay attention to the advancement in hardware and how can you utilize them. Read through these two articles. It's a really good one around how ARM's 64-based processors helps to improve the performance of .NET 7 and in .NET 8. Take a picture and read through that. So this is from Microsoft itself. Usually when they release a new version of .NET Framework, they do benchmark using perf monitors, or there are some benchmark tools they use, and that helps them to benchmark how well they are doing on different platforms. So we know that we need to modernize. So usually the customers, when they modernize, what they do is they first move away from .NET legacy frameworks. So they first do the upgrade from .NET version 2.0 to 4.8. They bring the last .NET framework into 4.8. Doesn't necessarily mean that they get the application working on 4.8. They just do the code upgrade. Once they migrate the code, what they do is usually 90% of the time what we see is they move ASP.NET Core ASP.NET applications into ASP.NET Core, put them on Linux containers, and get them working. Right? And by doing so, they reduce the Windows licensing cost. About 50% of instance running cost if you use Windows is on Windows licensing. And nowadays, to run a web server, you don't need Windows, right? So most of them are running on Linux, which we already know, like in your day-to-day operations, you may be using that. Once they've done this migration, which anyway they need to do, because Microsoft officially sunsetting 4.8, the next steps they take is reaching the database. So this is where they move into Postgres or MySQL or sometimes into file system. You'll be surprised to see how many databases can be converted into just file system, files on the file systems. You change the primary key to a file name, and you can get it. And it's much efficient and cheap to use that. So that's not necessary to get your application everything on very expensive databases. And finally, they move into some kind of SaaS product to change the business model. So to assist this, one of the tools that we have released is called .NET Porting Assistant. Raise the hand who are using .NET Porting Assistant before. Anyone? Alright, this is good. So .NET Porting Assistant is a free tool available for you, especially if you find legacy code base in your company and you want to upgrade that. It gives you, you can load it and you can scan the program and it will give you some upgrade paths. So here's an example of that. So I just loaded our famous NerdDin applications, a few .NET applications into that. And what you'll see is that it gives a portability score. Higher the portability score, more easy it is to migrate. And it will also give you ways to migrate the code from legacy .NET full framework applications into .NET Core applications. Here you can see I have Log4net 2.0.3, and this is on the legacy .NET framework, and I want to move into newer version of .NET Core. And it recommended me, hey, some of the APIs are not supported, but if you upgrade Log4net to this latest version, then you should be in good shape, right? So the tool allows you to go into detail and then analyze how easy it is to do the migration. You can go into code level, exactly look which API is not compatible. You can even go into your library level and then decide which projects are not supported or to what percentage that it's supported. For example, in some libraries, when the Microsoft upgrade from legacy.NET framework, full framework into .NET Core, some APIs are deprecated. Like for example, if the underlying operating system is not supporting that API operations, let's say there's an API that writes to system event log, which Linux does not have, you don't have where to use this API. So you can locate these locations exactly using .NET Porting Assistant. It gives a dependency graph, so you can check which classes are heavily dependent, so you can start start modifying that code starting from the nodes that has a lot of dependencies. So every time when you modernize, you need to touch these center nodes and then start modifying your application towards the leaf nodes, right? So play around with .NET Porting Assistant. It's a free tool that you can download from internet. So this is good. So now you have your application running. You got your application ported into .NET Core. Now where do you run it? Now my colleagues are going to walk deep down into different platforms that you can run it. So you have, for example, the classic VMs you can run it. Who here are using Azure App Services? Yeah, we have some people using that. So similarly, like AWS equivalent could be AWS Elastic Beanstalk. But today we are going to focus on a few services, AWS Fargate and AWS Lambda. So let's get our application working on a platform called AWS Lambda. Who heard about AWS Lambda before? There are a lot of people? Yeah, this is awesome. So it's similar to Azure Functions. So what it allows you to do is to respond for events. So you have this AWS Lambda, it's a managed compute platform. It provides compute and memory. You can connect your network, of course, into that. And you can use any language you like. So that includes Python, Node, and for guys like me and you, they have C#. You can even run container images as a serverless function, right? Some events happen, so these events could be somebody uploading an image, user login, and you respond for that. And the result of that one could be right into a database or interacting, processing an image. So let's create a very simple Lambda project and then publish it into AWS Lambda. So here I have, so once you install AWS Visual Studio templates, you will find start to create a Lambda project. So this Lambda project is, you can create, for example, a web API, you can create a ASP.NET web application. So I select this ASP.NET web application template, punch in some parameters, and then it's going to create the solution. So in Visual Studio, like you will find this all the on the side hand side that you can interact with the AWS services. So that includes, for example, there are some virtual machines running from the Visual Studio itself that you can interact with them, publish them. For example, in the AWS version, we have something called CloudFormation to automate and deploy the infrastructure. So let's say you want to deploy a virtual machine or create a network. So that comes as CloudFormation. So using Visual Studio itself, you can interact with these services. So let's now go into our simple ASP.NET Core web application and then try to publish it on Lambda. So this is running on localhost, simple ASP.NET Core web application. What I did was, I created S3 bucket, a place to keep my published website. So that will have all the DLLs. And I changed my configuration file to point into that S3 bucket. And then all what I can do is to go and then click publish to AWS Lambda. It will compile it. It will publish that compiled DLLs into the S3 bucket or the binary location that we created. Right? So go next. And it's then going to publish this one to AWS Lambda. So behind the scene, it's going to use AWS automation technology called CloudFormation to publish into AWS environment, right? So it's going to run a CloudFormation behind the scenes. You can see that it's creating that infrastructure behind the scene. And as part of that, it will create your API endpoints, your Lambda functions, and also your load balancers. So this looks good. Still deploying. So at some point in time, you will get create complete. And the next thing is to go there and look at your endpoint. So here you see the API endpoint. My sample application is published. This looks great. And if you go to the public facing website, which in case I have brought, this is all created as part of that template that we gave for you. You have your serverless application. This is a typical ASP.NET web application running on Lambda. So it's very easy to use. You can also bring your own custom images if you want. Let's say a container image that you want to run, and then execute it. So this looks all good, but you may ask, hey Sri, real world application you don't directly publish into production, right? You have some kind of DevOps pipeline. So today, I'm going to use Azure DevOps as my preferred DevOps platform and then publish it into AWS. Who here use Azure DevOps as their CI/CD pipeline? Anyone? What technologies you guys use? Don't be afraid. I love Azure DevOps, right? It's a great product. And in fact, a lot of our customers use Azure DevOps, and what we encourage our customers to do is keep using your preferred platform and try to integrate it with AWS because we don't want to change the way that your developers are doing. Right? So Azure DevOps is a CI/CD technology. It has a way to manage projects. So what I'm going to do today is to integrate Azure DevOps with AWS. So what are we going to build today? We are going to create a very simple Fargate cluster. So this is like a platform to run containers, right? Much simpler than Kubernetes, tightly integrated into AWS services, and most of the overheads of Kubernetes is hidden behind the scene. Right? So I have a very simple ASP.NET core application running as a service on this Fargate. And inside that there are two containers, right? Version 1 running. And I have my load balancer connected into that, which the users connect. Right? This is great. What I'm going to do now is to get an ASP.NET core application, put it into Azure repository, and then kickstart an Azure pipeline that's going to build this application using an Azure agent. Now, Azure build agents, or Azure DevOps build agent, you can run it on EC2 AWS virtual machine. And this virtual machine will have permissions to publish into AWS services. So what will happen is that it will create an image, and it's then going to publish that image into another Elastic Container Service. And once it publishes that Elastic Container Service, it's going to start a new container, and it's going to tell, hey, service, move the traffic from the old containers into the new one, and then the old containers will slowly be decommissioned, right? So you have your website running with the latest version. So let's go there and build this. So I have my, of course this is a Keynote, I of course recorded all the videos, that's easy. So I have my simple ASP.NET Core web application. Here you find the Docker files. It's a very simple application, and this one simply builds the container. So this is as of now running ASP.NET 6. So here you have Azure DevOps, and I already created a pipeline here. You'll find that my pipeline has some steps. So let's go, this is my repository. So I have the steps to build the application, right? So that includes .NET build, test. So all these are .NET normal publication steps. I like to, in pipelines, write everything with command line instead of using different plugins. So here you can see the build agent pool is an EC2 instance, right? So I have installed Azure build agent on EC2 instance that has permissions to publish into AWS services. And if you install AWS plugins, you will find some plugins available on Azure DevOps Marketplace. Do things like upload into S3 bucket, start a confirmation template. It's easy to interact with them, so if you are not a fan of writing code, you can install these plugins on Azure DevOps Marketplace and then configure them to work. So I have this Fargate cluster created. The Fargate cluster is the one that provides compute to my containers. So as of now, I have two containers running here. And it's connected to the load balancer that I showed you earlier. Very simple ASP.NET application that gives a welcome message. So my job now is to change this home page, publish it to Azure repository, and kickstart the pipeline. So let's go there and then change this home page to a new home page. And then I'm going to publish this to Azure repository. Right? I just type the system environment, the machine name, commit it, configure my hooks in Azure repository. That's going to kickstart the Azure DevOps pipeline. All right. So here now we have the Azure DevOps pipeline. So if you refresh it, you can see that it's building behind the scene. And after a while, of course, it's going to download the source code, build it, and then publish the container image. Now this is about 10 times the speed of the actual process. It takes about a couple of minutes, but because we are in time tight, this is fast forward version. That's going to build all the container images, and then publish this one to Amazon Elastic Content Registry, and then tell our ECS service, hey, go there and then take the latest version. So the pipeline is completed. So let's go back into Fargate and then check what's the status there. So this is the initial state. If I now refresh this, you will find the new 2 containers that will come alive. Alright, there you have it. So these are the 2 new containers that started, the version 2, and it's in the provisioning state. So at this stage, it's just provisioning these new containers. So if you go to your website, it is still running the version 1, so you will not see the changes there. But let's give a couple of minutes. This is of course the fast forward version. After that, once you refresh that, it will publish these images, and if you refresh this, ideally you should get the new message, the new change. Okay. So that's how easy to integrate with your existing DevOps pipeline, whether it's Azure DevOps or Atlassian version, could be Jenkins. So different countries have different preferences, different organizations have different preferences. I love using Azure DevOps. So if that's the kind of technology that you have, feel free to use it. There's no pressure for you guys to use the AWS services. Choose what is best for you guys. This is good. So we got our application running containers. The other thing is how we can be productive as developers, right? Raise hands who are using some version of AI programming in your day-to-day programming. Do you use GitHub Copilot? Raise who else? Oh, we have a lot of GitHub code. That's also productive. Who is using ChatGPT to write your code? Alright, everybody is using that. You really need to you'll be surprised to see the level of capability. I'll show you some examples, right? Some of the capabilities that you may not even think they can do, right? If you have time at the end, I will show you that. I asked ChatGPT or this generative AI technology to give me an API to get foreign currency rates. It gave me that. And it returns an XML. Then I asked it to, hey, read from this XML and return me the Korean won exchange rate. It then writes an XML query, XPath query, to get the exact currency rate. And it's amazing how it reads that XML document, it understands that, and then returns that value. So we have our own version of a code assistant called Amazon Publisher. It allows you to develop your applications faster and quicker. Available for C# of course. And more important, it's a free service. So you are more likely to be more productive if you use these code assistant tools. So let's start with a simple example. So the first thing you need to do is to install AWS Toolkit. And once you install AWS Toolkit, it's available on Visual Studio Code. You go to this small extension, and then you run your code whisperer behind the scene, right? So usually it's in post state, so I already started it. So it's now going to give you recommendation for your code. So you have this, I'm going to create a very simple calculator, right? So what I'm going to do is to say, hey, I want to create a calculator. I give my intention as a commit. A class that can perform simple mathematical operations, and it gives me the recommendation. Right? So class calculate add. I can press the tab key, the control key to get different recommendations. Alt C Windows to get more recommendations. So this is all that code which we are writing the code. So the subtract method I need to multiply numbers. That's great. So I keep asking for recommendation and keeps giving me values, right? So I have the divide method, but it then ran out of ideas. So let me do another command, a function to calculate the power of a number. So this is now you start giving, okay, this could be the good part, right? Of course it missed math.power, but okay, this is still working, right? Then you can see that there's a problem with the divide by zero, right? You can't divide numbers by zero. So if I write if, it's then recognize, what if the b is 0? And it's going to throw divide by 0 exception, right? So it's even smart enough to understand, hey, this is the type of exception I should do. So I'm going to create a new class called mines to keep currency information. So I'm going to give the recommendation like, hey, I want a class to keep the currency information and recommended me this class body. So all that typing that you have to do is now gone. And then I say, I need a method to return the list of all supported currencies. It type all these currencies, right? And it's a great way to write test cases, right? So remember, when you're writing test cases, it's kind of a boring thing. This is an easy way to write test cases. So let's ask some more currencies. So it gave a recommendation of Korean won, New Zealand dollars. That's great. But I now want an interface to save this currency information to a database. So I say I need an interface to perform count operations, create and delete operations. So it gives me like different templates. So it could be like even type like a generic types it's giving, right? So you can circle through the one that you like. I like this interface. So let's select that. And then let's go to some programming and then say, hey, I want to create a DB storage. Now you can store the currency information in the file system or database, but I want to store this one in a database. So I implement that interface. The normal Visual Studio IntelliSense is still available for you if you are going to do that. So implement the interface. You have that infrastructure, all the method implementation. That's great. Now I want to read all the currencies from the database and return them. Now what's the problem here? Is it going to be a Postgres database, file system, XML document? The AI can't understand that, right? So it's not going to give you a good recommendation because it's clueless. But we can give it some clues. What we can do is to, so here you can see it's running, it's out of ideas to recommend. But you can add some libraries. So let's say we add some NuGet packages. I'm adding Microsoft SQL Server NuGet package. It then knows based on the context. It's going to read all these files and it knows now, hey, when you say that you want to save this database to a database, you are actually talking about Microsoft SQL Server, not Postgres or any other database. If you ask now the same recommendation, it now gives you the SQL connection. See? Now this is great, but I don't want a connection string here. It looks something like it needs to be a private property, maybe in the method body. So I'm going to move this connection property into a private property, right? So I move that. So let's say private connection string. It gives that template of a SQL connection string, right? Instead of another connection string. Now what we are going to do is to ask, hey, now give me get all function. Now here's the beauty. It took the connection string from that previous condition, other than again typing. So it's kind of smart. So it knows that you are going to select from currency table, right? And then let's ask some more recommendations. Okay, command execute. So if you have done any system data programming, you know these are like very familiar classes. So you can now iterate through the kind of all this typing and then type. So let's do an update operation. I need to update the currency table. Gives me text key, take the connection string from that private property, and then update. So you see, you can see it sent all the SQL statement, and it's updating the rate, not the currency code, because that's the one that you usually update. Right? So that looks all good. This is all it's typing behind the scene to improve your performance or your productivity. So this looks good. It wrote all this code with you working behind the scene, giving your ideas, and you can write the code. Now this is just for C#. It's available for Python. It's available for other languages. So go ahead and have a look. So it works with your favorite IDEs. So that includes your Visual Studio, JetBrains solutions. all the reference tracking is available. So let's go through the final topic, Microsoft SQL Server modernization. So Microsoft SQL Server is a great product, we all use that. But the challenge is that about 70% of database running cost is on SQL licensing, right? And this is a database, right? It's a very commodity service. It's a great product, but expensive. So if you go through the Stack Overflow survey, you'll find that the most frequently used database nowadays is Postgres. And if you're not using Postgres, then there are some things that you're going to missing out. So let's go to the Doublefish. It's a new technology that we released a couple of years ago to move SQL Server applications into Postgres. So let's say you have a Microsoft SQL Server application. You want to move it into Postgres. You can, using some tools like schema conversion tool, you can move the database quite easily, right? The challenge is how we are going to move the application code. Because you have libraries, you have system logic there. But with the Doublefish, you need to change all this. If you are using a traditional way of migration in the code, you need to rewrite the application. But with the Doublefish, you start a Postgres cluster, Amazon Aura, you can even run it on premises if you want. It will create two endpoints, Doublefish endpoint and a Postgres endpoint. You connect your application's endpoint into Doublefish endpoint and it understands Microsoft TSQL proprietary TSQL dialect, right? And you can keep your SQL Server application working on Postgres. It can work side by side with Postgres, and behind the scene, it's a Postgres database that's going to provide that storage. Released on Apache 2.0. This is so famous, it's even available on Alibaba Cloud if you want, right? So it's an open source project. So let's go through an example. I have this very complex application called Complete Nuke, about 400,000 lines of C# code, 30,000 lines of SQL tables, and I'm going to a very complex one, about 800 plus code procedures, and I'm going to move it into Postgres. So this is the application, about 400,000 lines of code. You have extensions, this has its own marketplace, this has its own site settings. You have recycle bins, a traditional ASP.NET application running a CMS system, right? So how we are going to move this one into Postgres? So the first thing I'm going to do is to export the schema. I use SQL Server Management Studio, export the schema, select the tables and functions I want to export, and I export only the schema, and then I have the schema export. I'm then going to run this thing called Doublefish Compass. It's going to analyze that schema and then give me a recommendation how complicated this migration is going to look like. So it's going to be a report like this, but very detailed. Now, of course, it's very difficult to get all the things compatible, right? There are going to be some gaps. For example, some data types like geospatial data is not available on SQL Server. So in this report, it gives me assessment saying that, hey, out of these 800 plus stored procedures, only 23 need our attention. I can convert all the tables except one. So you know in advance what are the challenges that you will face when you try to do this modernization, right? This looks all good. So when you are doing a modernization, do not try to fix everything, right? So here I have this complex stored procedure. I don't want to change everything. So here what I did was I just commented out the stored procedure body. I then throw an exception because I don't know whether this stored procedure is actually used in the application. So when you are trying to move an application code, don't try to fix everything, just comment out the body, throw an exception. Then during testing, you will find it's going to throw an exception, right? And then you can see, okay, when I use this part of the application, it's going to use this stored procedure. Then only you should go there and use it. Otherwise, it's going to be way too complicated to understand, especially if you haven't used this code base before. Doublefish Compass also has some rewrite operations where you can rewrite incompatible features. Sometimes you need to do manual fixes. So here there's a function that converts URL into, it removes unwanted characters in the URL. And somebody wrote it in as a SQL Server function. So if Battlefish Compass exactly tell, hey, this is the incompatibility, this is where you use it, just go there and then change it. So I manually rewrote it, took me about 15 minutes. And after that, here's the, I'm using SQL Server Management Studio. Because you have wire protocol compatibility, you can see behind the scene it's running Battlefish out of Postgres. But you are using this familiar tool like SQL Server Management Studio. So this is all Microsoft TSQL language. I'm running it, but behind the scene it's Postgres, right? And you can use tools like SQL Server Management Studio if you want, simply because you have wire protocol level compatibility. So this is a Postgres database behind the scene, right? It created all the tables when you ran that command. And finally, you have you're going to merge the statement that I've manually fixed. And this is all good. I'm going to execute this manually fixed function. That got executed. And I'm going to load the data. Yeah. And so all this data is written in Postgres, in Microsoft TSQL language, but behind the scene getting executed. So I have this Battlefish cluster. You can see there are two endpoints, right? One for Postgres, one for Microsoft SQL Server, one for 3.3 port. And all what I'm going to do in my application side, I didn't change any code. I just changed the connection string to Postgres endpoint, the Battlefish endpoint, right? I'm still using system data client class. I restart the application so that you can get the latest connection string. And let's go back to the website and then check whether how it's working. So now this is using Postgres behind the scene. I can log in, I can create a page. And then you can publish a page if you want. And then it will show up in the database from the Postgres side. So let's publish a quick page. Alright. So you can see that it's running Postgres behind the scene and got the content got saved into a table. So these are the capabilities available for you. My colleagues are going to, there are going to be some hands-on labs that you can try. So make sure that if you want to learn more of these technologies, sync with AWS, and we have a ton of hands-on labs which we can run to your teams inside your organization. Do a POC, right? We support POC credits if you want to do any testing. Being again sync with our AWS colleagues so that they can help you. We can also loop you with AWS partners. There's a very matured partner networks in Korea who can help you to assist them. The beauty is they have access to AWS funding, right? So if you want to do a POC, we will lead you with funding. So be in sync with them and discuss your use case, and we will fund part of that project for you to migrate from, let's say, .NET Full Framework into .NET Core or containers. So enjoy your time, guys. It's super excited. I'll be over there. So if you want to have any questions, feel free to be in sync. Hope you enjoy this session. Thank you.